Hey everybody, this is Larry. This is day 18. Some days I just forget what day it is. The Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's farm. We have number 70, climbing stairs. You're climbing a staircase, the end steps to the top, climb one or two steps. So this is Fibonacci, right? I don't know what to say about this one that I haven't always said. I think I've solved this like 4 times already. Probably I have 4 videos or something. I don't know if this is true, but 5 times even. So I don't know what to say about this one. But it is Fibonacci. It is very fundamental. It's probably too easy on interviews now, though. I probably have said the same thing before because I don't know. This is like you could say that I'm a finite state automata or a state machine. I just say the same thing every time I see this problem. But I was asked this on an interview, but that was also 2 decades ago. So your mileage may vary. But today I would consider it too easy, right? I mean, it is a good practice, and same thing I said yesterday, which is that if you see problems like this, if you see easy problems, while you're practicing, do it as fast as you can. Obviously, on an interview, you may want to slow down. Just maybe not slow down, but just be more deliberate about it so that you don't kind of like rush yourself into a silly mistake, which I've been known to do many times. Yeah, I don't know what else to say, but yeah, hope everyone's having a great week. It's really cold. It is 20 degrees here in New York, -4 degrees. I just ran for a run, so I'm kind of just a little bit gassed and tired from that. But yeah, Fibonacci, I mean, there are a couple of ways you can do it, and we'll play around with a couple of ways. Like, for example, you can, this is something that I would also advocate if you're a beginner with dynamic programming. Be a little bit careful about which direction you go. What I mean by that is that for this problem, it is symmetric in a way. And what I mean by that, by symmetric, which is, I guess, a big word if you're new to this, is that you can kind of go backwards or forwards and it'll give you the same answer. And what I mean by that is, man, this is like me asking like why or what do you mean every like 5 seconds on every little explanation. Today I'll draw something out, and also as I'm trying to do this month at the very least, whenever I see problems that I've already done, we'll do an extra problem that a random RNG problem that I haven't done before. Anyway, so let's say you have some steps, right? Very ugly steps. Don't trip on it. But yeah, what I mean by symmetry is that that you have to get to. I guess it's actually kind of like this. You have to try to get to this step, and you have to try to figure out the number of ways to get to it. And the number of ways to get to this step is just the number of ways to get from here or here, taking one step, and then so forth, right? I mean, these. This stuff is way recursive, but of course, in this particular problem, what I mean by symmetric is that I'm gonna change the colors real quick. What's a good color? Let's change green. That's like a weird green. What I mean by symmetric is that's weird. Hang on. Is that you can actually go up or down, and you would get the same answer, right? So here you just go right, and same arrows, same things, right? And so what's wrong with this? There's nothing wrong with this. This problem, like I said, is symmetric. It's perfectly fine. You get the same answer going up or down, right? But I just want to point it out because, especially if you're watching this and you've already done this many times, and you maybe not all of you, obviously, but maybe some of you may struggle with certain types of dynamic programming problems, not this one. And one thing to note is that not every dynamic program problem is symmetric in this direction, in this dimension. So you just have to be careful, and it is mindful to kind of think about. I think a fun exercise, especially if you're trying to level up a little bit in dynamic programming, is to think about whether every problem can be symmetric and how would you write it the other way, right? So if you kind of wrote it going up, you think about why it's symmetric. Play around the maths, play around the proofs, play around the logic, and then see if you could go it the other way. That's all I would say. Other than that, I mean, like I said, this is a very Fibonacci problem. So most people should definitely know how to do this. Like, you will only get harder problems than this on interviews. I mean, when I say stuff like that, obviously I don't mean 100%, and it also depends on where you interview and stuff like that. Just as a caveat, because it's easy to be pedantic, especially when you're in a field where you're defined by edge cases. Then being pedantic is kind of nice. But all right. So yeah, so let's just say so count step from n or something like that, right? Is equal to if n is it n is equal to 2 means it takes 2 steps. Okay, so let's just say that we'll go backwards, right? So if it's equal to 0, that means that you have one way to get there. Otherwise, if n is less than 0, we return 0 because then you've over jumped. I don't know if that's the. Otherwise, you can return count step n minus 1, plus count step n minus 2. And one thing that I would say for competitive programming, of course, is think about the bounds, right? And here 45 should be enough. Fibonacci actually grows at about 3, or is it 3 or 5? I always feels like every time I say it one way, someone corrects me. But yeah, the constant phi, which is like the golden ratio, which is like 1.61 or whatever it is, right? Or like, what is it, 1/1 plus square root of 5 or something like this, right? But yeah, so is that to the n, right? So it's 1.6-ish to the n power, which is slower than 2 to the n. So you can plug that in, I guess, and really check about the bounds to see if you need like a 64-bit int. If you're not in Python, obviously. In Python, I get to be lazy, right? So yeah, so that's basically the idea, really. And here, we'll obviously test this. Let's test it for small numbers first, because I know that is going to time out. But yeah, but of course this is exponential, so that's why we need to do memorization. And here's what we will do. Yeah, and I get comments about this every time I write this, but I just like writing it this way because it's very the code is self-documenting. You can write it in another way if you like, and you can write it in many ways if you like. I don't But I definitely, this is intentional. Maybe it's a little bit too much, but but that's okay, right? It's just being very explicit about what you want and what the code does and stuff like this, right? So yeah, so it looks good, and if it looks good for the biggest number, then it's good, and it's only 1.8 bill, so yeah, give us a submit. No silly mistake today, which is good. 1388-day streak, and there you have it. That's all I have for today for this problem. We'll do a bonus random problem after, so stay tuned. Hit the subscribe button if you want to check that out, and do an extra problem with Larry. But yeah, stay good, stay healthy, to good mental health. I'll see y'all later, and take care. Bye bye.